Hello, this is Dr. Liu, and this video is about how to interpret the analog read values. So, as you can see on the left side of the screen, we have serial print and analog read A1. I have something else on A0, so I'm reading A1 instead. So what's on A1 is a potentiometer. So depending on how I turn the potentiometer, the value will change. If you look on the right side, these are the values that the potentiometer is outputting. So I'll be turning the potentiometer with my screwdriver. So this is pretty much the maximum already, although it doesn't really reach 1023. Right? If I turn the other way around, the voltage starts dropping, the numbers start to drop. Right? So that's the other side of the potentiometer. So the question here is, what is this value and how do you turn this value into voltage, such as the 325? What is that in terms of voltage? So what Arduino is doing is reading a number between 0 and 1023, and this value should be mapped between 0 volts and 5 volts. So you divide this number by 1023 and then you multiply it by 5. That is how you scale it to the 0 to 5 volt, which is the power supply of the Arduino is 5 volts. So to do it programmatically, which means you make that adjustment right here in the code. Here's how you would probably first try this analog read. You go to the right side. So outside parentheses, the inside parentheses here, over 1023, and then times 5. So this would actually give you the right value. And let's see. So with the calculator, the 325, 326-ish, this is actually live because the potentiometer is pretty, pretty stable. So you rarely see the value change even by 1 bit. So 325 divided by 1023, then multiply by 5. So we should see something around 1.6 volts. Right, so that's what this value represents, 1.6 volts. Alright, so let's upload this code and see what happens. So give it a minute. Well, this is the first time I'm compiling since I logged into the computer, so it was a little slow. Alright, so instead of showing 1.59 or 1.6, it's showing zeros. So let me try my luck with the potentiometer. Let me turn it one way. Okay, 0. And turn the other way around, still 0. Okay, so what happened here? What happened here is integer math. So the analog read returns an integer value, which is between 0 and 1023. So if you divide that by 1023, according to integer math, anything less than 1023 divided by 1023 gives you a 0. So that's what the quotient is. And then 0 times 5 is equal to basically a 0. Well, it depends on how you play with this. You can multiply this by 5 first and divide by 1023. You'll get some values because you multiply by 5 first instead of divide by 1023. Well, neither way is what you're looking for. So what you want to do is you don't want to use integer math. You want to use floating point math. So all you have to do here is you turn one of these two numbers, the two numbers being 1023 and this analog read result. One of these two numbers being a floating point number will force the other to become floating point number, so they don't do integer math anymore. So here's one way to do it. Just make this return a float. Okay, so let's upload the code again. Okay, so now let me turn my potentiometer. I turn it so it's no longer 1.58. Okay, I guess I just turned past 1.58. Oh, there, 159, 158 again, right? So this gives you the floating point results. I see that. So it gives you a floating point result, and this doesn't really go to 5 volts just because the potentiometer's construction. Um, there's a little bit of residual resistance that is basically that the center tap cannot move past. So it ends up with, well, 4.9 instead of 5. So this, with a summary, I'll conclude this short video is the analog read gives you an integer number. So all integer numbers involved together will use integer math, and integer math gives you either 0 or 1 depending on whether you're bigger than the 1023 or you're less than 1023, which is always equal or less, so you get a 0. And the solution is to turn one of them into a floating point number. If you don't wish to turn the analog read into floating point, you can also do this 1023.0 that turns it into a floating point. And I can remove that float, which I consider a little more obvious what I'm doing. So this way will give you the same exact results. Let's just check it for a second. Okay, same result, right? But if you turn the 5 into floating point, this is useless because the inner math between excuse me, the analog read and 1023 is already done. So it's already a 0, and multiplied by anything is still a 0. So this will not work. Right. Thanks.